Hello, my name is Anmol Bering, and today's topic for this video is ultrasonic detection of hydrogen damage in boiler tubes. And this pertains to the boiler tubes in the power plants, and hydrogen can occur sometimes under if there is an upset in the water chemistry. So it only occurs at low pH levels, and it will only occur at if there is an upset in the water chemistry. So under normal operating conditions, hydrogen damage should not occur. So you may run the boiler for 10 years, 20 years and nothing should happen. But if there is an upset in the water chemistry, the pH level drops, it can happen within days or a week or so. And if it happens, then there will be boiler tube failures. And when there are boiler tube failures, some inspection has to be done to make sure to avoid future failures. Otherwise, you will repair one and the next one will pop, and you repair the next one and another one will pop. So it has to be taken care of. Now the inspection has to be done methodically, and this is the way you should address it. So it occurs at low pH level when there is upset in the water chemistry. It will only occur in areas of high heat flux and wherever there is flow interruptions. So inspection is done only when needed. So let's go to that side of the board now. Now, when this is like a boiler, typical boiler, and here I'm showing the burners. Their burners are here, and they are being shown on the north wall. So the high heat flux area will be the south wall. That's where the fire is going to. And normally the hydrogen damage failures will happen on the wall which is directly opposite to the burners, because that's a high heat flux area. So this is where the failure will happen, but you still have hydrogen damage in other tubes. So what you have to do is that once you already have a failure, you know this general area where there is possibility of hydrogen damage. So that's where the inspection should be focused. In addition to that, you could have hydrogen damage in areas of flow interruptions, which are going to be like these bends here, and also at the circumferential valve on both sides and at the valve root also. So this is going to be the areas of inspection, and when hydrogen damage occurs, it's going to be like this. This is the tube, you have hydrogen damage, and in boiler tubes, whenever there is hydrogen damage, it will be associated with corrosion. So both of them will happen at the same time. So you have corrosion and you have hydrogen damage. So the hydrogen damage in the boiler tube is going to be like this. It's not going to be over a long length of boiler tube. Normally these are about 1 inch to 2 inch diameter localized areas where hydrogen damage occurs, and if it occurs, then this will pop up, and then we do the repair in that local area. So I think this one I covered. Your burners here, hydrogen damage failures will occur, and then you scan just this area. So only this general area where the possibility is high for hydrogen damage. There is no need to scan the whole boiler, because it's not going to happen everywhere, only in the areas where you already had the failure. So how is the inspection done? It's pretty straightforward. Since hydrogen damage is associated with corrosion and it looks like this, we just do an inspection to look for those areas of corrosion in the high heat flux area. So here are the steps for the inspection. This is a boiler tube which has been cut out from the boiler, which was experiencing hydrogen damage. So it has some spots with hydrogen damage, and I have a dual probe. This is just a regular UT machine. I set it up on a 1 inch screen, and the tube diameter is 3 inches. So thickness is about 0.32. So what you do is that you start here, and you can see the thickness on the screen is 321. That's a nominal thickness of the tube. And then all you have to do is that you have to scan it, not do spot checks. You have to scan it 100% like this, and scan it on the fire side. So keep going down, and as you go down, you'll see right here, see 260, and that's a spot with the hydrogen damage. It's because we already had failures in this area. Then you go back and it'll go back to the nominal thickness. Here again, see 320, and then you go down, and again there's another spot here. So if you think about it, the inspection goes really fast. I'm here, and you go here, and you can see the signal shift to the left, and that's where the hydrogen damage is. And what you would do is that instead of just doing one scan the way I'm showing you, I would do a scan here and go a little bit to the left and go a little bit to the right and do 3 scans, and all on the fire side. I've done this inspection in many boilers, in many utilities in the US and in Canada, and really I've always found it, I have always been on the money to find the hydrogen damage, and with a success rate I would say 100%. So if you need any help, you can always contact me, and this is my email address is nde@nde.com. As you can see, it's a process. It's not just going straight forward and start doing the inspection. You have to have a whole process and then do the inspection. Thank you very much. Thanks for your attention.